Hey everybody, this is Larry. This is me going over day 21 of the Leetcode daily challenge on Leetcode. Hit the like button, hit the subscribe button, join me on Discord. As usual, I actually solve these live and I do the explanation live. So, however, for this problem, I actually had a lot of issues with it. It took about 40 minutes for me to do it live. So this little preview is me going over the solution and hopefully in a distilled way, and then you can watch me solve it actually more live afterwards, after I explain the solution a little bit. Yeah, so feel free to hit the like button, hit the subscribe button, and join me on Discord and all that other stuff. But yeah, so the idea behind this problem is just greedy, and just trying to think about doing it in an intelligent way. I did not, and it took me a long time to figure it out, and it's just about case analysis. At a certain point, I actually so the core idea that I would say for this problem is that, okay, so let's say you have an array, right, and let's say we start with negatives, meaning that we subtract k from every element, right? Well, okay, so then this is one snapshot that gives us a possible answer, right? Don't worry about the rest of the stuff yet. We'll go over it as we get closer. Let me also zoom in a little bit for better visualization. Okay, it's a little bit too close, but yeah. But okay, so given that we can always subtract k from all the elements, therefore we can take our initial min as just taking the first element and then the last element and subtracting them to get the delta, right, the difference. And then now I was using the term greedy a lot, but I would say actually another way to think about it is that, okay, so now let's do a brute force type thing. Oh yeah, and also first of all, we have to sort them so that it goes in increasing order. That is a key part of this problem, so definitely do that, and that's one part of the code I left in actually. But yeah, because then it gives us properties that we can use later on, because we then assume that given two adjacent elements, the early element is going to be smaller than the later element, right? So then now, because of that property, we can make some adjustments, right? Well, let's say we just pick endpoints at random, like make this bigger. Well, does that really help? Maybe we can figure it out. And if you do it that way for random number of them, there's going to be for input size of n, it's going to take 2 of n's possible combination to switch this up to positive, right? So the first thing I would notice is that, let's say we started with subtracting k from every element. We can switch, or we look at the first element, right? Well, the thing is, given the first element, let's switch this to adding k, right? Well, what happens? Well, there are only a couple of cases, which is that, okay, this is now either still the smallest element, and if this is still the smallest element, then this is going to be, then we cannot make this element smaller, we cannot make this element smaller, and all the way through, right? So that means that the answer is set in stone once this is true, right? So then we can return immediately. Let's say this is an element, now this plus, we don't actually do the actual sorting, but let's say we sort it and we move this to the bottom, because now it's the biggest, right, at the latest. Well, in this case, now you just do the math, because this is a new example of, okay, well, now the next number, that's going to be the smallest, and then so you just compare it to the biggest element, right? Which is, as you know, we do a comparison, and if this number that you just added is bigger than the biggest number, then we have to do some maths, right? And there are a couple of things to notice here is that when we add this number, this only makes the number worse, or that's not true actually. But if you add this number, it doesn't, it may change it, but we're not testing that yet. And also, if you look at every other number, like if you add this, change this to a plus, well, this is going to give you a worse answer than if we just leave it to this, right? So, and the reason why that is because if this is the biggest number, then the balance between these two numbers, the beginning and the end, if we add this, if we change this number to the add, then by principle, this will either be, well, this will either not change the answer, or this number is bigger than this number, which would make the number worse, or the answer worse, right? So then this is our new element, right? And then the other case that we can go over, and this is just case study in a way, is that, okay, let's say this is in the middle, right? Well, then what happens? Well, what happens is that, okay, let's do two things, right? One is we check whether this number is the delta between the first number and the last number. Check to see if that's the smallest. If it is the smallest, then that's a possible answer, right? If it is not, then you just move on, it's fine, right? And then now you go to the next number, which is this new number. Now we're on this number. Okay, right? So then now here, now we try, okay, this is a similar way, but it's not the same. But now we try again. Okay, that's what happens if we add this to a plus. Well, there are two things, right? One is now this is the biggest number, right? And if this is the biggest number, let's just call it the second. I'm just going to add 2 for second. This is for first number. If this is the biggest number, then okay, we changed our range. Let's just check again, right? Do a check from here and here. So basically, this is your second index, and then your third index. Check to see whether you have a better answer, or this is in the middle, right? And this is something that when I solved it live, I missed a little bit. Was that this next number could be in the middle, but you know that because we both add both numbers by k, this has to be here, right? So this number has to be smaller than this number. So it's either here and at this number. So then if this is the case, again, we check, this number, the new third element, and then the last biggest number, right? We just update the best value, of course. Or the other case is that actually, if we go back a little bit, actually, if we put the first number here, right, and then now we change it to a plus, we put this in here, right, because of what we said that this number has to be strictly less than this or greater than this number, and because this number is bigger than this number, then the newest smallest number is actually the first number, the added version of the first number, right? So then in that case, you track the difference between this new min number and then the old max number. So that's basically all the test cases, and in that way you keep on going from left to right, checking what happens if we change this to a plus one at a time. And once you're able to do that in a consistent way and go through it, then that's how you get the code and the answer. So I basically did this live, and I ran into a couple of observations that was a little bit wrong, and that's why it took so long. But yeah, so I'm gonna go through my code real quick to kind of go through what we went through. But again, after my explanation, you could watch me solve this live, which was a long video, and you can feel free to fast forward for it. But hopefully you'll see where I did wrong and how I attack a greedy problem, even though it's a very tricky one for me. But yeah, so we start with subtracting every element. We take the initial best answer as the first and the last, because the first is the smallest and this is the max number, and we update the max. And then here, for each iteration, well, we go through this thing, we change the current number to add k, and we add it twice because we have to first compensate for the fact that we subtract k the first time, and then there are a couple of cases, right, which is that, okay, if the new number that we just added, if it's the smallest if it's the smallest number, which we said is smaller than the next number, because if this number we add k is smaller than the next number minus k, then a sub index will always going to be the smallest number, and you cannot do better. So then we return best here. and we double check that the smallest number is this new number, or it could be the first number, right? Because of that visualization that we did, where the first number is always going to be, and this first number also we already added, but that added number is always going to be the smallest number going forward after a certain point, right? So yeah, so that's our one of our case. And then another case is, okay, if this new number that we just changed to addition is between the next number and the max, meaning it is in that scenario where we're in between, then the new best is either the next element, or actually this is not necessary, so this is a little bit confusing. But yeah, so this is either the next element, so either the next element, which is the negative version, or negative k, we took k from, or the previous min, which is the smallest number with the addition, right? So one of those minus or subtract that from the max, and that's our next best answer, and we continue. Otherwise then a sub index with the addition is the new max, and it's always going to be a new max until the next number that you updated. So then we said max is equal to this number, and then again we subtract it from either the next number, which is the negative version and it's just the new min, or the old min, which is the added version of the first element, right? And then at the very end we just return the best result from all these possible segments, and that's how we get the answer. It is kind of tricky, even though this code looks really short and mostly straightforward. But I hope that, yeah, and this is technically just a sub index plus minus 1. But this is really tricky, so I would definitely recommend going through it a little bit. So what is the complexity of this, right? Well, we're dominated by the sorting, so it's going to be n log n, because this is just O of n from the rest of these loops. So it's going to be n log n time. In terms of space, it's going to be linear space because, well, it depends how you want to define it. If we are able to modify the input array, which doesn't really make sense, because if you put this as an input and someone changed your input as you respond, then that's not an acceptable answer. So I'm going to assume that, even though in code I actually don't use extra space, I'm going to assume that you make a copy of this, and you should. So you should just do something like, let's just say this is B, which is, we just make a copy of B, right? So this is going to be linear space because we make a copy of it and then we use it later, and that's fine because you really shouldn't change people's input. But if you want to, say it's okay for in place, then technically it is O of 1 extra space. But yeah, and of course I would also say that you can actually do this for, you could do this part by just having O of 1 extra variables by keeping track of the min and the max in a clean way. However, because you're still sorting, that still modifies the input, so that's still going to be O of n space if you don't want to modify the input, even though here I modified it to the next degree. Again, this is a tricky problem for me, so let me know what you think. And you can watch me solve it live afterwards. It's a long video. Feel free to watch in 2x or whatever your favorite speed is. And even my explanation is like 14 minutes. So it's way long. For me, it's tricky. And I will talk to y'all later. Bye-bye. Hey everybody. This is Larry. This is day 21 of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, smallest range 2. So I do solve and explain these problems live, so if they go a little slow, feel free to fast forward and jump ahead. Okay, so given an array of A, you can either choose minus K or X of 0K. Okay. And you're trying to get the smallest possible difference between the maximum. Okay. So the first thing I'm doing now is just looking at the constraint to see whether we could play around it a little bit more. So each number is going to be up to 10,000 and K is less than 20,000. So we can probably do some sort of greedy, either on, I mean, there are a couple of ways to do greedy, to be honest. You can sort A and then, you know, move certain numbers to increase and move numbers on the bigger side to, you know, small. So there is certain greedies of that. We might have to be careful to play around with the numbers in between, and yeah, and I think that's roughly how I would think about it. Yeah, it's just going to be some sort of greedy and some sort of like jiggering, if you want to call it that, to make sure they're right. But it's going to be some sort of greedy. And with the edge case being like, if you have something like this, you can, you know, the 3 is going to be outside the bound, either you add it or subtract it, and that's going to be part of the trickiness as well. So yeah. I'm still trying to think about the actual implementation. Like I feel like the idea is going to be right, but there maybe also be edge cases because greedies are kind of tricky to kind of get right. And you know, in the easy case, these are easy, but this is probably the tricky case where it will inform me how to get it. And you have to add or subtract k, right? So there's no choice. But okay, let's first, and noticing that it's only be 10,000, we can actually just check the bounds a little bit. But let's see. I think so. What I'm thinking right now, just as a dot, is whether I can binary search, right? And the tricky thing to note is that even though I said greedy is a thing, if you greedily add a number to the left, you can actually subtract a number from the right, the biggest number, and it may be the new min, right? And that new min may poses a problem in terms of thinking about it in like, you know, like the invariant of you going from left to right on may not hold true, because you assume that first element is going to be min, but that might not be, well, that just might not be true, right? And then you have to redo the math, and that may be a little bit tricky. And then my question is, my thought is, would you ever, well, I would also say that you always want to increase the first number no matter what. I think that's a base case. And the reason why that could be is like, let's say you have 1, 2, 3, and k is, say, just 10,000, something big, right? If we make it negative 9999, it's always, no matter what, it's going to be the same as, or like, you know, this is the same responses. Like if we subtract k from all these numbers, that's going to be the same response as adding k to all these numbers, right? So in that sense, we don't get any new information. So then for me, then okay, the only way that the answer can change from that base case is if we add to it, right? And then what happens when we add to it is something that we have to kind of think about. And from that, I also think about whether we can binary search from that, right? And there are other ways to binary. There's definitely a binary search one, but one that takes advantage of the fact that this is 10,000, I think. So one binary search would be just, okay, let's say the smallest number can be negative 20 or negative 10,000, because that's the smallest number that you can go from 0 to negative 20,000. Then you can binary search the max number, or not. Can you? Is that too slow? That may be too slow actually, but that kind of idea may have some merit. I don't know. But yeah, as I said, I think I am going to sort, and then I'm going to take the first number and increase it by k, right? And then there are a couple of scenarios. Okay, so let's set our base case, which is the best, which is equal to the last element plus, minus the first element, right? And this is, even though we don't do any modifications with k, we can assume that we just subtract every element by k as we said. So that's what this means essentially. And we could just do this. Now that we changed by the first element by k, what changes, right? Well, we still have to process whether to add or subtract from the next elements, and that is curious. Because in this case, I feel like, I would also say that these are the type of problems that I'm actually a little bit weaker at, because I feel like it's going to be some sort of greedy, but then it's about like implement it in a way that I know to be correct, which is always and proved to be, you know, at least in my mind, correct. But I'm always, in my mind, I'm just thinking about different inputs, and as I go for different inputs in my mind, I'm like, okay, well, actually that's an edge case and that wouldn't work. So I'm just trying to think about, okay, what to do about. So if it's sorted, we could maybe look at them one by one, which is for x in the suffix, right? Okay, I think I have an idea, right? So there are two choices that it can do, right? Okay, I think now I'm coming up with an invariant, which is, I think, maybe, to be honest, a little bit dependent on a sort of a dynamic programming, but not really. But now I think what I want to do is just keep track of the min and the max and going through them one by one in some way. I think I had that idea, but now I have to articulate it in a good way. But basically, for each number, right, do we want it to be the new min? So basically, if okay, I think now, I know that this is a long video, but I think I have another way to articulate this, which is actually, which is that, okay, this concept of min and max, right? So basically, now I look at each element, and this is sorted, so it's going to be in an increasing order. Let's say we, subtract k, and then in this case, the smallest element, it's going to be in the first element, right? And then now, just for, try to figure out how to do a possible, all possible things. Well, let's say we convert this to a plus, right? Well, what the hell happens? Either this is still the min, which is fine. That means that this is our new answer, I think, actually, because if this is still the min, then no matter what we do, we cannot do better than what is already given, right? Because if this is the min, if we add k and it is still the min, then we can, the second number cannot be bigger, but you can make it worse by adding and so forth for all the way to the last number where if you subtract it, then it is going to be closer to the number that you added, and that's greedy, right? But obviously if you convert this to a plus, then it's just going to make the answer worse also by obviousness. Hopefully. Okay, so those are the two cases, right? So then now let's say we add this to plus and this is no longer the min. So now here we say, okay, we look at this sub-array, but we look at this element. If this is minus and this is a plus, then, well, there are two scenarios, right, as we talked about. One is that this is the new min. If this is the new min, meaning that, this plus, the first element is bigger than the second element, minus k, then this is the new min. So then we can, treat this as a new array, because now we could just ignore this because this is going to be inclusive, except for an edge case where this plus may be the biggest number in the array, which, yeah, I don't know, right? Like for example, in this case, if you add instead, then you may get negative 9998, negative 9997, right? Oops. But again, in this case, we can do the math, and yeah, but then this would be the next min element, right? So I'm just trying to think about invariance and what doesn't change as we do the loop. But in that case, we can, set this to the max or whatever, and then go on, right? So, okay, so the two cases, let me type them out so that I feel like I may be repeating because I'm still trying to go through this problem in my mind. So yeah, if second element is now the smallest, then first element with plus is either in between, meaning if this element is in between here, then it's not interesting at all, and then we could just remove and ignore, or it could be the biggest element between, or is the biggest element, right? And then the other case is what we talked about already, which is if the second element is not the smallest, then we are done because the first element with a plus is always going to be the smallest, and any changes will only make it worse. Okay, so I think this part we talked about, and I think that makes sense, easy to code. But this part, there is an additional concern I have, which is that, okay, what if it is in between again, then we're done. Done with the first element, to be clear. And then you can kind of, think about this as a sub-problem and then just solve it for the sub-array, ignoring the first element, right? Or if it is the biggest element, then what happens? Well, if this is the biggest element, then, if this is the biggest element, let's call it, how do I want to phrase it? So now the plus, we moved it to the back, and this is done, right? So just to be clear, like we don't have to edit this anymore. I don't know if the exclamation makes point, but that's gonna, if it's the biggest element, then there are two things to do, right? Which is, okay, well, if this is a subtraction, then we already have the sub-problem to solve, which is that we assume that the first element is the biggest element. Then, we check to see if this is the new best answer, right? Otherwise, we also want to check the plus. And then now it becomes a little bit, I wouldn't say recursive, but iterative. Now going forward, we go, okay, let's have a plus. And then now we look at the next number. And then here we ask the same question, right? Is this the newest number? Is this between the thing? Or is it, the newest big number, right? If it is the newest, then we update it and put it in the back again. And of course, we don't process this more than, twice. But yeah, so I think now, that was tiring. And I hope that you're following along. I know that this video has been going on for about 15 minutes. It is longer than usual because I haven't, I don't know how to solve this in any faster than you saw me. So this may be the first problem, the first time I've seen this problem, and I don't think my usual pattern, like it's not a problem in which you're like, oh, it's just this algorithm, right? So I had to work it through. So I hope that the thought process, even when I was trying out in my head without code, different examples or different processes with respect to like binary search, and then it didn't work and stuff like that, right? Hopefully this is a good template for it. And now that I have this, we can just code it, right? So okay, so we sorted it, we set the best is equal to this. Now let's I think there are ways that you can keep track of stuff, but I think for the first iteration, I'm going to just write the code as dumb as possible, and then we could clean up afterwards, right? So yeah, so let's write this. Okay. So let's start with n is equal to length of a, and then now we can do for index in range sub n. So yeah. Okay, so if index, we already handled the original case, so let's, for the sake of maths, to be consistent with what we showed. I know that actually you can make some implicit implementation things so that you don't have to actually implement it, but let's actually just do this where a sub index, let's subtract k, and then we'll start again with another pass. You can actually be a little bit clever about it, but I think it just makes it a little bit confusing and have potential for mistakes. So for index and range on the second pass, now we want to see if we can add this index, right? Add k, and of course I'm going to add it twice to compensate for the fact that we subtracted once, right? And then now we check. Okay, and we're going kind of the thing, right? So next element is equal to a of index plus 1. We'll go over the edge case with respect to this last element later, maybe. Well, no, I think we can actually just subtract from 1. We don't need to care about the last element now that I think about it, because for the last element, you never want to add it for the same reasons that, because if you add the number to the last element, it can only make the answer worse than optimal. At least it'll be worse than this case, right? Where every number is already negative. So I think we can safely do this, though leave a comment if you're unclear about that. Okay, so then now we check. Okay, so just use, no, okay, that should be fine. Okay. Right. So, okay, so if the next element is bigger than a of index, or even equal to, because if it's equal to, like I said, you can only make the number worse by increasing it, and because of that logic, you could propagate it for the other ones. So then here, I think we can return immediately because of the same thing that we said, which is that, yeah, if let's say there's a plus in front, because we already added the number, and if the next element is smaller than, or if this element is bigger than this element, making this a plus can only change the answer, and if it stays a negative, then you don't change the answer, right? And don't change the answer in a positive way. Okay, so we can return early. So then now, if the second element is now the smallest, which means if the opposite of this, so this is an else, I'm not writing the else because we return early here. So then, okay, so then if a sub index is either in between, so if this is bigger than the last element, so this is the notation for the last element in Python, in case you're not in Python, but if this is, let's do the other one. If this is in between, then we're done. Then we can just continue. But we have to do a check. We should have to do a check for the best, which is that, okay, if this is the case, and of course, this, let me actually rewrite this because I know that I want next element to be clear, but I think this is actually clear at this point, right? So this is if a of index is greater than a of index plus 1, right? So in this case, that means that if you want to be explicit about it, and I think this can be Leetcode too as well, actually, because same thing, right? So if a of index is in between this, right? This is what I'm saying more explicitly. I know that we didn't have to write that, but I figured I might as well write it for readability reasons. So if this is in between, then we can continue to the next index, because we know that we can just throw it away, essentially, right? In a way, because we know that if this is in between, then we're done, because we're not going to make the answer any worse, right? And then now, if this is if a of index is the max. So else if a sub index is greater than a sub 1, and I know that this is an else, and from this is always true, but I just want to be explicit with respect to here. So yeah. So if a of index is the max, what happens, right? Well, then we update the max element. Okay, yeah, we update some max element. So max is equal to a sub index, right? And first, let's start having this is equal to the last element is the max. And here, then actually we have to update this, because now we're comparing it to not the last element anymore, but the max element. It's a little bit confusing the way I explained it for sure, but this is my thought process as I'm coding it live. So hopefully that's okay. Okay. So that's basically the update loop, but we don't have an answer, obviously. And yeah, and you know, we could figure it out, right? So how do we want to figure this out? Just to be correct, right? Because, okay, so if this is bigger, then this is already the best, so we don't have to update. Here, if this is in between, we also, well, in this case, then the smallest is going to be index plus 1, and then max is the highest, right? So we can do, I don't know if this is necessary strictly, but I'm going to write this so that, oops. Just to be explicit. So it's max minus index plus 1, because this is now just the new smallest of the entire length, right? Okay. And then here, the max, of course, now, well, and actually we could do it afterwards. It doesn't matter, because this is always true, right? So, so we just change how you write it. And then now the new max is now the new thing. And also, you know, the smallest is the next element, as we said, because otherwise we always returned. So it's going to be just this number again. And then at the very end, we can return best. Okay, cool. This is a very long video. I hope this is understandable. Let's run it real quick to see if we have any typos or weirdness or just wrong answers. Yeah, let's do this. Oops. Ooh, wrong answer. That is a little bit sad. Well, I changed. Oh, did I put max? I think I remember putting max by accident, because I don't know. I think I've just been talking about max so much. But we obviously actually want this to be min, because that is what they ask you for. The smallest possible value. Still wrong. So this should be 2 and this should be 8, right? So why is this wrong? For this default case. That is weird. Why did I get 10? I mean, 10 is in the beginning, right? So, okay. So let's check real quick. I think let's also just put impossible so that I can kind of make sure that, I don't know. Let's just print A. just helping me visualize. Is this for the last one? So that means that this doesn't even get here, right? If this is bigger than that, then a sub index is already the smallest element. Oh, I think I just don't update it on the first loop, though this is still wrong for the last loop. But let's move this down here for clarity. So yeah, I think I just have to keep track of a little bit more things. So okay. Oh, n is 2, so this should go for this once, right? Yeah, 2 and 8. But we never update the best. Is that normal? I guess not. Max minus a of index, because a of index is the smallest. Maybe I just assumed that it would get updated previously, but maybe not for the first element. So we can run that real quick. And that should be good for this case, but now we have an issue here. Why is that? I think it's because I don't... Maybe I update this too aggressively here. Because I remember seeing, and it's good that our impossible never kicked, by the way. But we could print a real quick. A lot of debugging today. Debugging Sancho. So, let's put this in the back. Okay. Oh, no. Max is 4, but this is 6. Huh. Let's print out more things. Just to be sure about why I'm getting wrong. Yeah, max is 6. So why does it give me 1? Yeah, that's odd. Do I have a typo somewhere? Because 6 minus 3 obviously would be 3. Is this wrong? No, I mean, because this is what we update when we're here, right? So we only check 4.0 and 6.3. Do I update best somewhere by accident? I mean, this is only the other place where we update best. So that's a little bit awkward. I probably have like a really silly typo somewhere. Because I don't know, that's just been my MO lately, unfortunately. But like 4 minus, I mean, all these invariants are right except for bests. Let me just take one out, pass it around. Oh, because this MX. Oh, wow. I have to be a little bit careful. That's just me being careless then. Because what happens is that this gets updated with the old max before this condition. And for some reason, I thought that I could generalize by putting them in the same place, but I actually needed this first. So, okay. I mean, it's good that my ideas are right, but my implementation, it's a little bit bad that my implementation is not. Let's give it a submit because I'm a little bit tired and we're about half an hour in. Hopefully it's good, but it is not. Oh no. Okay, let's see. Let's put it back in. Why is that wrong? So we have 1 because we... How did I get 7 in the middle? How did I get 5? Oh, did I sort this? Yeah, I sort this, right? Yeah. So I have 1, 3, 10. So that's 4, 7, 6. That's right. Oh, that's what I guess what we want it to be. Except for that, there's something wrong when something is weird, because this should not execute like this for sure. So what do we want? Okay, let's say what did you say it was 1, 3, 10. So basically, what is our ideal code? 1, 3, 10. In theory, we want this to be 4, right? So we want this to be 5, 7, 6. And what does that mean? That means that when we have a 5, we actually 1, 3, 10. So this is actually -1. This is 6. So when 5 gets up, 5 is in between this. So we do a min of the max and this. So this is 7. This gets updated to 7. This should be good. And then the next iteration, we have -1. Oh, I missed a case, I think, where we, okay. Well, now we try. No, I think I thought about this case, but I handled it incorrectly for sure. Where we add the number to 7. And now we have to care about the previous number, because by definition, the last number is going to be bigger than this or smaller than this number. So then this is no longer the min, even if you add it. I made a wrong thing here. We're done with the first element. So this is not true. I was wrong on this. We're done with the first element if we keep minus, or we that's why initially I had a concept about keeping the min element, but I think I got a little bit confused afterwards. But okay. Whew, this is hard. This is a tricky one to get right, at least for me. This may not, I don't know. If we keep minus, or the previous element is the smallest. Okay. So how do we... So if this is in the middle, so we have to change this case, right? So this is the min if so basically it is just a sub 0 then, right? It's either, oops. No, this is either a sub 1. This okay. So I think my thing is, and I'll explain a little bit. If index is 0, what happens, right? If it's big, then we just take a sub 1. So best is equal to min best mx minus a sub 1. Else, if it is not the 0, then what happens? You add a number, but then that means that your smallest large number, and assuming that you tried adding it to all the previous prefixes, your smallest number is always going to be either the next number, which we have, or the first number, which we added on. So it's going to be min best mx minus the min of either a sub index plus 1 or a sub 0, which a sub 0 now has the added stuff, right? Something like that. I want to say. Oh, still wrong answer though. So definitely missing some other elements as well. Because basically here we want So, okay, so for the second element, well, we have to update here as well because... So I only looked at the first index and assumed that would go recursively, or iteratively, but that was wrong. This is a tricky one. Like I said, greedy problems are hard for me anyway. So if a sub index is the new max, then what is the min, right? The min will be, again, this similar thing, right? Okay. Yeah. Either this next element or the a sub 0. Okay. Because, again, in this case, we have to take the smaller of these two. And a sub 0 already has the addition one, and a sub index plus 1 has min, or has minus. There's a lot of case analysis for this one, but and I'm going to do a quick summary at the end and also go over deep. Ooh, wow, I should test more, but I just am a little bit lazy today. Or like we're 40 minutes in, so yeah. So okay, 3, 2, 10. Why is that wrong? So we have 2, 3, 10. We have the answer we get is 3, and expected answer is 4. Expected answer is 4, and that should be obvious, is because this is just 4, 5. Oh, sorry. Oh, wait, what is the 2? Yeah, 4, 5, 8, right? So 4 and 10 are 8, or 4 and 8 are 4. So how did I get 3? Dun dun dun. Let's also print a sub 0. Long day. So we want this one. 4, 1, 8. Okay. This one is 7. Wait, what was it again? 2, 3, 10. So you add 2, so it's going to be 4, 1, and 8. So 4 is going to be in the middle. That's fine. We have 1 and an 8. Okay. So in between, that's good. But then now we have to look at the next number, right? So then now we look at the next number. It is this thing. And I think this is probably, I just didn't re-evaluate. I just didn't look at this case again because I think previously, well, that case has been wrong every time. So that's probably what it is returning. So, okay. So basically what happened is that, okay, you have the 3. Where's the 3? Or the 1. And then now you add 4 back, it's going to be 5. It's already bigger than this number. So then we return the min of this, which is not true, right? This is actually the min of this number and a sub 0. A little bit rushy and lazy. Okay, so this is actually it's a good problem. I think I made a lot of silly mistakes. Okay, accepted. So yeah, really the 40-minute problem is very unfortunate. But at least we finally got it, and hopefully you saw how I stumbled on everything. But I think that's the thing with greedy, is that sometimes you see a pattern and you think you're right, but you have to prove it and you have to be careful. And I did not do either of those things. So that's why it makes these things hard. And hopefully you watching me solve this in over 40 minutes, it's a good, example of someone who struggled with this one, even if they're supposed to be good. But we did work through it. We did solve this problem, even if it was a struggle. So hopefully you learn from it. Okay, so what's the complexity? It should be, this is an easy complexity. First of all, note that we sort, so it's going to be n log n at least. And then after that, each element, we just look at over one operation. So again, it's going to be dominated by the n log n. The rest, then the space, we actually don't use any extra space. However, we do edit the input. So I'm going to call this O of n because we should not edit the input, and be careful, you should make a copy and don't edit the input. So yeah, so it's going to be O of n, And yeah, that's all I have for this problem. I think. Well, okay. Yeah. I mean, it has to be all event, and you can actually do this without editing the input, but it was still like you could keep like min and max, kind of what I was trying to go for. If you keep the min and the max in variables, then this would only have one extra variables. However, because you still sort, that means that you're still modifying the input. So it's still gonna be linear time if you are committed to not, or linear space, sorry, if you're committed to not modifying the input. Cool. That's all I have for this problem. Hope this was interesting and hope you learn from my mistakes and my thought process as I go through them. Let me know what you think, and I will see you hopefully tomorrow. Bye bye.